Good afternoon, everybody. Welcome to the CISL seminar. This is Jeff de la Beaujardière. I'd like to introduce our speaker today. First, however, just one quick announcement. We may be modifying the times of these seminars. You may get a survey about that coming out pretty soon. So we're just gonna, this would be for the year 2022. Keep an eye out for that possible survey or other question posing. So today's speaker is Dr. Anna Pinheiro, Privette. She's a senior program manager with Amazon's sustainability group. Anna was trained as an environmental engineer and as an earth sciences researcher at the New University of Lisbon in Portugal and at MIT in the United States. She did her doctoral research work at NASA Goddard Space Flight Center, and as part of her project, she spent a couple of years running scientific field work sites in Africa to support a NASA International Field Campaign. While working later at NOAA, Anna worked on the U.S. National Climate Assessment Project, focusing on bringing more transparency and traceability of the data sources supporting this climate report. After spending most of her career at NASA and NOAA as a scientist, she then led projects for the White House climate portfolio, including the Obama Climate Data Initiative and the Partnership for Resilience and Preparedness, both focused on delivering better access and use of federal climate data to support researchers and decision makers. Anna will be speaking today on the Amazon Sustainability Data Initiative. So Anna, if you could unmute, get your camera going, and yes, there you go. Great, thank you. And we'll take questions via Slido as usual. You should see the link at the bottom of your screens, and when Anna's done talking, I will moderate those questions. So thanks everybody, and Anna, thank you very much. Take it away.
Great, thank you. Can you hear me okay? And I apologize, I'm recovering from a head cold, so my voice might not be as clear as normal, but hopefully we'll be okay. Okay, so, well, first, thank you very much for the opportunity to be here and share with you some slides and information about the Amazon Sustainability Data Initiative, or ASDI as we call it. As Jeff said, I'm with the Amazon Sustainability team. I'm also the global lead for the program for ASDI. So let me jump into it. And to provide, let me see if I can make this work first. Yes, okay. So for a little bit of context, so ASDI, or the Amazon Sustainability Data Initiative, is a tech for good that Amazon launched publicly at the end of 2018. And I'll tell you more about it, but just to provide a little bit of context, why we're working in this space. So I don't know how many of you are familiar, but Amazon actually made a big commitment to go net zero in 2040, which is 10 years ahead of the Paris Climate Agreement. And so that really means that we have to turn our operations and our entire business upside down to understand how to decarbonize our operations, include transportation, production, the cloud, everything. And so there's a lot of innovation happening inside of Amazon and collaboratively with the outside world as well, because obviously this is such a big endeavor and requires so much innovation that no one company can do alone. But in addition to this internal work that we are doing, Amazon has also realized that there's an opportunity to play an enablement role in the world more broadly. And that's where programs like ASDI come into the picture. The idea here is, can we leverage our scale, our technology, our infrastructure, and bring that to the community, in this case, to focus on creating more innovation and more problem solving in sustainability space. And in particular with ASDI, one of the things we are dealing with or trying to address is this challenge related to data, right? So as you all know, working in the place where you work, there's more data now than ever before. We might not have exactly all the data we need, but we have a lot of data. More satellites are being launched than ever. Models are creating higher resolution products. Internet of Things devices are streaming more data. And so the reality is that we have all this data, but the data is dispersed everywhere. The data is growing exponentially, so the amounts are very large, in some cases terabyte and petabyte scale of data sets that are really hard for just everyone out there to use. And then there's a lot of diversity in the data, right? Not necessarily making it easy to make it interoperable and to analyze it together. The expertise required to analyze those data sets is increasing. And we really have a very diverse set of tools and requirements out there that make the system even more complex. So what we're seeing in practice, and that probably some of you have experienced, is that if you are a scientist or a researcher that is trying, for instance, to study a problem related to climate change, the amount of data required to study those processes are dispersed across different domains, so traditionally are stored in their silos. And so every single one of those scientists has to go through the effort of identifying the data sets they need. And once they identify those, they have to go find the data, acquire it, store it, clean it, and then finally they're at the point where they can extract actual knowledge and insights from the data that can lead to the advancement of the space, right? Climate science, whatever field we're talking about. So this is a process that is repeating itself over and over again. So if we step back and look at that, and we realize the amount of effort and time and what we call undifferentiated heavy lifting that is taking place, that could be devoted towards really advancing the science, it seems like this is a great opportunity where the cloud could play a role and try to mitigate this problem. So this is how ASCI really came into existence. And the main focus of the program is to significantly reduce not only the cost and the time, but also the technical barriers associated with taking these big data sets and really generating insights and knowledge from it. So before I actually tell you more about the program itself, one of the things that is important to recognize is that there's a core change in the traditional approach of doing science that is required for us to fully implement this moving forward and take advantage of this technology, right? And the traditional way, as you all are aware, is this move the data to the compute resources, right? There's a group like yours or NCAR or others all over the world that produce these authoritative data sources that many consumer users around the world can use. But what's happening traditionally is that all of these researchers or users are getting their copy of the data, right? So they're moving the data into their own computing facilities. And in addition to that, effort that everyone is putting into that process, there's also an additional cost, which is in terms of the carbon footprint, right? When you think about that, especially for big data sets, if we keep repeating over and over the storage, thousands of times all over the world, that actually starts to make an impact in the amount of carbon and energy that we are using. So what we're really talking about here is shifting their way of thinking and move from taking the data to the compute to bringing the code next to the data. And so the idea is, let's work with groups like NCAR, NOAA, and NASA, UK Met Office, and all those groups outside around the world that have this data that is really critical and foundational for the problems we're trying to solve. And let's bring those data sets to the cloud. It doesn't necessarily need to be one copy of the data. We perhaps have to have several different formats or versions of it, but let's really minimize the amount of data out there. There's several advantages of doing that. If you put the data in the cloud next to the compute, again, all this effort of moving the data around, keeping track of versions, having to secure the storage and the compute to be able to analyze the data, that all those issues become like minimized, right? So that's really the shift that is required for us to fully take advantage of this process and technology. So the theory of change here is, if we take all those data, talk with the different communities around the world, identify what are those foundational data sets that the majority of the people need to address a given problem, and then work with the data providers and bring the data to the cloud, make it openly available to anybody and accessible, and then put it next to compute and all of these tools and resources that are available, and offset the cost of that experimentation, because we're putting in the cloud. Of course, there's a cost associated with working in the cloud after a certain period of the free tier, but we have resources to offset that. Will this process really lead to the generation of much more knowledge and information and tools that can be shared with each other and advance innovation at a much faster pace? So the bottom line here is, can we accelerate the data to knowledge pathways by removing all of these barriers that people are dealing with over and over again? And so we built this program on top of 3 core pillars to try to address those needs. The first one is focus on democratization of data. The second one is enabling access to compute. And the third one is promoting knowledge exchange. And that's really that pipeline, basically fitting the pipeline that I showed before. On the democratization of data, again, the idea is to identify those foundational data sets. And then the approach we take, because we leverage an existing program on AWS called the Open Data Sponsorship Program. Previously was called the Public Data Set on AWS. You might be familiar with it. So if data sets qualify through that program, what we do is basically we encourage that data provider to bring the data to the cloud and make it publicly accessible to anybody in the world. We cover all of the costs of storage and egressing associated with that data set, but the data provider or the owner of the data retains all complete control and ownership of the data. So they continue to own the buckets, they own the data, they just have to commit to distribute it and making it available to anybody in the world, and we cover all the costs associated with it. So that's the part of the data. We have now a catalog with petabytes and petabytes of data, and I'll show a few examples of some of those data sets, but that's kind of the part of the data that's democratized to make sure that anybody that needs a data set to generate knowledge is able to, as easily as possible, access it. The second component, again, is, as I mentioned, the compute. Having the data open is great, but we're not fully democratizing if we're not allowing people to take the data, analyze it, and extract knowledge from it, right? So the second component is it's basically primarily enabling access to cloud grants. And we have a dedicated cloud program. We have an open call for proposals. Anybody can basically submit a proposal and request funding. There's no cap. You have to justify it, obviously, but you would get, if you qualify, you'll be granted compute for a period of a year to work in the cloud and develop your application. And then, or your analysis. And then the third component is not, I see it as important as the other two. So you have the data, you have the compute, but we really need to encourage the exchange of knowledge in the community to understand, one, how to use the cloud. It's not a given. Many people are not familiar with it still. And so to fully take advantage of this technology, it's really beneficial if those that are more comfortable in the cloud, that know how to solve these problems using the cloud, can share that with the rest of the community. So we have created a series of mechanisms to encourage people to write tutorials, even in some cases to share their code, to have, to share their knowledge through webinars and blog posts and things like that. So in a nutshell, that's what ASDI is. So I would like to just briefly show you a few examples of the data types and the organizations we work with. They are spread all over the world. We have data in many different domains of sustainability. Climate and weather is one of the areas we've been spending the most effort building, because we really believe that's where we can make a big impact. But we have other things like a lot of satellite imagery and even data related to air quality and water, energy, oceans. So it's pretty diverse. So I have links to the ASDI catalog if you want to explore it. But since we are having a conversation here at NCAR, I thought I would mention that we actually been working with Jeff and his team to host some of the NCAR data sets on AWS through the catalog. And apologies, I have a couple of dogs in the background. They might want to contribute. So there's a couple of data sets that we are currently hosting, and we are continuing actually this collaboration and conversation and adding more data sets. But those are two that if you want to explore, they are part of your own portfolio. Let me just show you very briefly how you would access the data and what the data set, this catalog offers. Okay, so what you're looking at right now is the main landing page for the ASTI catalog. It's actually, it's a subset of a bigger catalog, which is the Registry of Open Data on AWS, that contains all of the open data that is currently stored on AWS. In this case, ASTI is a subset of those data sets that kind of span all kinds of domains that we have tagged that we believe are relevant for any sustainability related kind of study. So when you land on that page, what you see on your right side, actually, let me mention on the left side, you have a description about the program ASTI, but then you have a list of different categories like weather, climate, water, agriculture, and so forth. And that basically just tags that we have appended to the data that kind of structure the data in different groups if you don't want to go through the entire list. But on your right, you start seeing the list of data sets available. And I highlighted there one of the data sets that we are hosting from NCAR, the North America Cordex data set. And so let's just take a look. If you would click on that data set, what you would get. This is what you would get if you selected that data set. And in more detail, basically you have a description of the data set. And again, this is being managed by NCAR, and all of this information was provided by NCAR, and it would be the same for all the other data sets in our catalog. Their data providers would be providing that information. So it has a description, it has an updated frequency, it has a license. So in general, as I mentioned, for us to subsidize the data set, through our program, you would have to have basically some kind of open license, but be aware that the Registry of Open Data also has data sets that are hosted by other organizations. They are still open, but they might have other types of license. So it's always important to read the license. Some documentation. And then if we shift to the right side of that page, you actually have information of how to access that data set on AWS. So it has some general guidance, what region is it stored in, and what, like some basic commands to access the data. And then further down, this is an important part that I wanted to mention, because this is part of that promoting knowledge exchange. And so in addition to out of sight, which is, we don't have that in all of our data sets, but it's really a relevant type of information. So I'm glad NCAR put it here. But where you see usage examples, what you see here are contributions from the community that help others use these data sets on AWS. Generally, that's primarily code or publications or information related to the usage of the data on AWS. And so the value here is, again, if you have gone through some effort of creating like a Jupyter notebook or a tutorial or something that explains how to take data and put it through some kind of process to generate information that is relevant for sustainability in general, then we encourage you to submit a request to add that information into the system. If we accept it, it becomes listed. And so the number of tools and applications and publications varies a lot for the different data sets we have in the system. And obviously the things that have been hosted for a while have much more content than the more recent ones. So I encourage you to not only visit what is there, but feel free to contribute. That would be wonderful. Okay. I just wanted to briefly mention the second component, the open call for proposals that we have. So I put a link there to our email address too, if you have any questions, but just to demystify a bit the process, it's a fairly simple application. You have to tell us what is the problem you're trying to solve, and it has to be related to sustainability, obviously, climate change, food security, even understanding basic concepts or processes in earth sciences. Of course, that all fits under the umbrella of sustainability, which is really broad. And then we're trying to understand why did you choose the cloud, and why does AWS can provide a solution for you. We want to make sure that what you're going to create can be somehow generating knowledge to the outside community. So we support across different sectors. So we support private sector as much as academia, and governments and NGOs. So we don't necessarily require people to share their code and what they develop, but there should be some amount of knowledge or information that is creating this space and innovation and can be shared with a broader community. So that's kind of an important criteria for us, criterion. And the fourth question, it's mostly for awareness. There's no requirement that you have to do feature work in the cloud. Actually, we only fund exploratory work. So it has to be either prototyping, or you taking a solution that was on premise and you moving it to the cloud, or you're creating a new data set and optimizing it for the cloud. But if it's something operational, we won't be able to support it through this grant. So I just want to make that clear, but you might have an idea of how this fits with bigger plans you have. And so it would be good for us to know. And then again, we also prioritize work that is using data sets that are in our catalog. So please reference that, and that's about it. And then you send it in, and then it goes through an approval process internally. Depending on how much you're asking for, there's different levels of approval. In some cases, it has to go all the way to an advisory grant board, and so it might take a little bit more time, but normally we try to turn it around within a couple of weeks. Okay, so all of this is great, but really what we're trying to do here is create impact, right? And as I said before, I'm really sorry. Now we're gonna have this background noise with my dogs barking in the back. The idea here and the value is really in creating impact, and so what I wanted to show you is some of the case studies of customers that are leveraging either the data and cloud grants, or information or knowledge that was generated through the program, and that is creating some kind of impact in the world. And I try to choose a bit of a spread of different use cases that cover different sectors and applications. Okay. So, okay, the first case is actually in the private sector. This is an example of a startup in Australia that is using the NOAA GOES data. So for those that are not familiar, NOAA has this satellites called GOES that are primarily designed for weather observations. And so that data is coming in near real time into the cloud and made available to anybody. And so what Solcast has done is build a workflow or a workload on top of that data that is producing a radiation forecast, and is selling that to the solar industry. And so what we hear from, we actually get a lot of uptake of startups, and we support a lot of them because they are so nimble that basically what they say is, once you put the data in the cloud and you remove the cost of acquisition of the data and the cost related to the storage and maintenance of the data, it's very easy for them to experiment on top of it and just turn on and off processes on AWS as they need. And so the cost can be really limited. There's no really capital investment for them. So this is just an example of a startup, but we have a lot of cases like this. The other example, this is also in the private sector, and this is a company, this is more like on the ecosystem restoration and biodiversity. Dendris Systems is an European company that is using a lot of the satellite imagery, like the Landsat and the Sentinel and other data sets in the cloud to help, and use also artificial intelligence to take an affected, I'm really sorry, I probably should go close all the doors. Is it better, Jeff, if I interrupt for a second and go close the doors, or is that really disruptive? Sorry about that.
No, I think that's fine. Go for it.
Go close it? Okay, let me just close the door.
One of the little joys of working from home.
Very sorry.
No problem.
They don't normally do this. Of course, they chose to do this today. There's probably an Amazon person delivering something at my door. Okay. All right. So where was I? So, okay. So they're using a lot of the satellite imagery plus AI to try to take vulnerable ecosystems and help them in the restoration and providing those planners on the ground with the right information they need for that restoration. And they've done a lot of work in Australia, for instance, after the big fires they had a few years back. So that's a really interesting use of the data as well and the resources. And then this one, I love to tell this story just because it also demonstrates how, how easy and cheap these solutions can be created, and they can help a lot of people out there. Okay, so for a little bit of context, the Blue Dot Observatory is actually, it's kind of like a pro bono portion of a private company called Synergize in Slovenia. And they are using the Sentinel data for their own work and applications. But on the side, they also build this implementation where they're monitoring all of the water bodies at risk around the world. So they use the satellite observations, and they create an algorithm on top of it, and they are monitoring the change in the water levels. And they're doing all of this for 7,000 water bodies around the world. And they estimated that their cost is only $6 a month, because all of the data is being stored for free. And they basically, again, it's just turning on and off the compute. Okay, so that's an interesting story with value. And then there's very different applications too. Like, for instance, I wanted to mention this project, which is just kind of like, it's a bit more complex, but it also demonstrates the end-to-end application and the value of different services in the cloud. So StormSense is a project that is managed primarily out of Virginia Beach. And so, and a few other partners. But so what they're trying to do is deal with inundation and flooding in the area, right, in Virginia Beach. And what they do is they use the normal national network from, believe NOAA and USGS has these inundation sensors, but they also install their own inundation sensors and use Internet of Things to send that information to the cloud, where they use that as input to run some hydrodynamic models. And they use information from the national water model to validate their assumptions and their estimates. And then once they have those estimates for inundation and flooding, they push that information to Alexa, so that the residents can actually ask Alexa whether their location is at risk for flooding at a given time or not. So it's just an interesting way of taking different pieces of technology and data and using the cloud as a way to aggregate all of that. Okay, so that was primarily information from the private sector and the government, but I wanted to highlight a few cases where we are working with nonprofits. And one of the big focus actually of ASTI is on the democratization of data and compute to underserved communities, and a lot of it in developing countries. So we are partnering with Digital Earth Africa, and for those that are not familiar with it, Digital Earth Africa is, again, a nonprofit that is trying to focus on bringing Earth observation data to the African continent. And they'll use DataCube technology on top of that data to enable decision makers and a lot of the local communities and the governments of the different countries to, one, assess the impacts of climate change and also manage those impacts. They recently wrote a report earlier in the spring with the World Economic Forum, and they actually estimated the impact of bringing all this data into the continent, which is unprecedented, right? There's a lot of decisions they've been making that really don't have the data supporting those decisions, so that's really impactful. Okay, and then I have a few other cases and projects that I wanted to mention, just because they are a little bit on the edge. They're different, but they might show you a little bit of the art of the possible, of the things that can be done with when you start opening data out there. So in this case, this project is called OS Climate, and it's a subsidiary of the Linux Foundation. And what they're trying to do is to leverage the knowledge and the experience and the lessons learned from what we've seen in other sectors, like for instance in genomics, right? And the open source approach to solving problems. And in this case, they're trying to apply that to assessing and managing risk in the investment and in the financial sectors. So the idea here is, again, there's all this redundant effort, all the data that is needed for investors to understand if their assets are sustainable, or if they are aligned with net zero goals, or other types of metrics. Every time any one of those analysts is trying to do this work, it has to go and find all this data spread everywhere, right? And so the idea was, let's bring all of that in data together and put it in accessible in a centralized place. The data doesn't necessarily need to be there. It can be a federated system, but the access can be through this platform that will help the community understand what data to use for what are the methodologies that are accepted as standard or best practices. Let's allow the mapping of all these different crazy structures and standards out there, and then build this pre-competitive data commons, and then let the different companies then come and build that proprietary and competitive part on top of it. So they are using, so we are giving them a grant to do some of the development on AWS, but I also leveraging a lot of the data that we already have in the system. And so there's, as you can see, there's a very diverse set of partners at the table, most of them in the financial sector, but also some technical companies and cloud providers are at the table as well that are working with us. And this is a truly one of those collaborative efforts for the good of the community. So I'm excited about this one as well. All right, and then I couldn't, this is my last example, I promise. But I had to mention this one because it relates directly to NCAR and the work and the collaboration we have with NCAR. So very recently, we made an announcement of support to a collaboration with Silver Lining and NCAR to run the first ever full production climate model simulation in the cloud. And this is really relevant for many reasons, right? So as most of you know, cloud computing is extremely compute intensive. It requires a lot of storage. The data generated is really big. And so as a result, what we're seeing is that only a very small amount of people in the world really has the ability to run these models, but also to access the data and use it and analyze it and make sense of it in the context of their reality, so that they can create policy and make decisions that are relevant for their own situation. So what we wanted to do with this collaboration is, one, show that it's possible. Traditionally, cloud computing and climate modeling have not been, associated. So we really wanted to show that that's possible, and you can run it in the full production mode and create results that are meaningful and accurate. Just a second, I'm about to. Thank you. And then on the other side also, apologies, this is when my cold is going to start hitting me. On the other side also, again, democratize not only the model, but the data that is being generated, so that others can access the data and analyze it. So we're super excited with this collaboration. It's ongoing now. There's been a lot of effort put into optimizing and taking this gigantic model, putting it in the cloud, making it run and optimize all of those processes. And there's a few kinks that they were trying to fix, but it seems like they're pretty ready to start the full simulation production and make the data available to the world very soon. I wanted to mention, I was last week at COP, and we had a session both with Jean-Francois Lemarque from NCAR and Silver Lining, Kelly Wanzer, but also we had an additional guest in the panel, which was Dr. Chris Leonard from South Africa, Cape Town. And that was really, it really spoke to the value of opening access to models like this. And it was really interesting to hear him say, this is Chris Leonard, that they have very limited access, obviously, to the big computers and to the big models. So their ability to run these big models is really constrained by their compute, but also other issues like the power breaking all the time and internet access and other issues. And so he mentioned a new recent paper that just quantified the number of publications, research publication or scientific publications related to climate sciences that address or impact Africa. And I believe over 58% of those papers did not include a researcher or an author from Africa. And that what that really means is that they're being removed from the equation of creating the solutions that impact them directly, right? So this is where we see there's really an opportunity to open these models. It doesn't mean that everybody's going to be qualified to run these models, but the right people that can do it can be at the table and have the same resources. And then the data will be open as well for more people to be able to contribute to it, to improve it, to add to it, and to suggest new directions, perhaps for the science and for the applications. So I just want to thank you again for the opportunity. I believe we're going to have some Q&A. But again, if you want to learn more about the project, please visit our webpage or send us an email, and I'll be happy to answer any questions.
Great. Thank you very much. Let me see if I can get my video going. Okay. And thank you very much for that. Sounds like a great project overall. So far, there's 2 questions, both submitted by me as we're going. It's unfortunately with these virtual seminars, it's very hard to, read the room. There's no room out there. I don't know what, people are confused or not. So I would encourage people to submit any questions you have to the Slido. You should have the link on Vimeo. I'm going to start off with my 2. The first actually was more of a comment. So thank you. You had mentioned the CESM lens data set and the NA Cortex data that we published on AWS, thanks in part to the Amazon Open Data Sponsorship Program, or whatever it's the Open Data Sets program now. Forget the new name, and ASDI, right? Your group. And I did just want to mention to you and others that we are almost about to publish 2 more, the CESM version 2 lens, and also the data assimilation research testbed CAM6 reanalysis data set. So thanks for the sponsorship to get that on. Maybe I'll ad lib a question though, which is the end result will be 4 data sets that are similarly published in some ways, ZAR format, intake ESM catalogs, but they're still separate data sets. And meanwhile, other groups are also publishing data in the cloud, but each one has their publication. Each one has a separate data set, and you can find them on the registry of open data with a text search. But I haven't seen any tools that would let users say, hey, find me any data based on space and time, for example, without, as opposed to a text search or knowing the project or anything. Is there any work on sort of augmenting that registry of open data to allow spatio-temporal queries of available data sets?
Yes, and that's a great question, and something we've been pushing very hard to get. I'm not sure if it's going to happen at the open data level, but definitely for ASDI, we recognize that that's a very important component of the users that are doing sustainability work, the ability to search the data in a more user-friendly way, and also being able to search for spatial and temporal characteristics or variables. But what that requires is that we need to have additional metadata associated with the data sets. So there's a lot of conversation of bringing some stack metadata applied to all of the data sets, at least in the SDI catalog. So there's definitely a very active conversation happening in that area and resource allocation. So hopefully you'll see something soon.
And when you say stack, you mean the spatial-temporal asset catalog?
Yes.
Okay. Great,
yes.
great. Okay. I had another question, and again, I encourage others to ask questions too. You mentioned the Digital Earth Africa project. I hadn't heard about that. That's very interesting, and I'm just curious whether Madagascar is involved.
It
My
is.
father was actually born there.
It is.
So I know all I can. So yes.
Yes, it is, and so there's there's a lot of data for the entire continent and for Madagascar. I'm pretty sure that Madagascar is included, so I encourage you to go look at it. It's a very exciting project, and they're really doing some significant work in the area. This is actually an evolution of a previous project that we had supported called the Regional African Data Cube. It was initially developed by CISL in collaboration with UN and a few other partners. And the idea was to test this approach of building a data cube for 5 different countries in Africa. And the project was so successful that they ended up getting philanthropic funding to build it for the entire country, for the entire continent, and it resulted in Digital Earth Africa. But there's some things that are so basic for us that for them it was really impactful. Like an example was Ghana has a lot of illegal mining, and they're unable to track it regularly because they didn't have the resources to identify where the illegal mining was happening in their protected forests. So with the Digital Earth, in that case, it was the African Regional Data Cube, with the data cube data, they had satellite observations, and they applied an algorithm that detected when deforestation was happening, but also when standing water was occurring in the area, which was an indication of digging into the aquifers and getting water from the aquifers to get the minerals. And so that allowed them to easily deploy, like the right, resources to the ground to prevent that from spreading even further. So those are some of the applications that they've been using it for.
Excellent, thank you.
Mm-hmm.
See, can we, another question here by Brian Bonlander. Is the heterogeneity of user environments in the cloud a potential issue, or are there efforts to standardize the user spaces needed to compute?
I'm not sure I fully understand the question. And maybe Jeff, you can help me there. It's by heterogeneities
of across different clouds, perhaps? I'm not sure.
Because across different clouds, there's a real issue nowadays, right? There's always a way to work across different clouds if you containerize your code, but then you're not fully taking advantage of the specific services. So there's a compromise there. You can optimize your architecture and your code for a given cloud, or you can stay at a higher level, but be able to be portable, right? So I think there's the future is to have a lot more work to create cloud agnostic solutions. That's really the best solution for the user. But I think some of those things are starting, and conversations are starting to emerge, but we're not quite there yet.
And I wonder, just trying to speculate a little bit more on this question, whether if Brian is referring to one specific cloud, could it be the idea that, oh, some people are using Jupyter notebooks, other people are using, other software stacks that might, maybe a custom user interface or some other notebook-like thing, but not Jupyter.
Yeah.
Does the ASDI, would ASDI and the Open Data Program like to see us as data contributors and possibly of writers of things like Jupyter notebooks have more standardization in what we publish in terms of our tools and what our data set looks like, data sets look like?
Yeah, well, I actually would pose the question to you, because the way I see SDI is in that enablement role, right? We're going to the community and try to understand what are the big roadblocks that are preventing you from doing your work, and where can we bring the cloud and the cloud technology to help you with that. And so one of the values that we see in this open space of anybody being able to use whatever they want to use is that, right? Is that we are not forcing anybody to use one given tool or one solution that needs to apply to all. But it does interfere with the ability for people to share with each other as much, because then, of course, there's not as much standardization. So the question is, for the community, what is most helpful for us to provide and to guide you with? We tend not to set rules or standards. We more like enable the community to get somewhere, and then we support it. but we tend not to be the ones setting the direction because we don't fully understand all the spaces, right? Yeah.
Looks like there's a follow-up from Brian, but via Tasia. Brian replied, does each user receive the same environment for performing analysis?
So you just get the access to fully if we give you a cloud credit to work in the cloud, you get complete access to the cloud, to all the services. So there's no limitation. So you, yes, you will get the same environment. It would be the environment that anybody, even the ones that are paying, would get. And it's up to you to customize it and decide how you want to use it. And let me add a caveat there, because if you get a grant, traditionally, unless you're a power user and you don't need help, we team you up with some kind of a solution architect that will help you at least review your architecture and help you optimize it. So we don't necessarily just throw you there in the sharks. But and another thing we've been trying to do, and we're trying to steer more towards, is this idea of actually creating more sustainable architectures. There's very different ways of coding, and there's ways of building architectures that are more sustainable from energy consumption and other perspectives of sustainability. So we're trying very much to also provide that kind of guidance for, especially when we're talking of running big models that consume a lot of energy. Yeah.
Great. The next question is about running models by Kevin Rader. He writes, climate models typically require hundreds to thousands of processors to make fast enough forecasts. But in the past, the cloud has not been able to scale well to those sizes because of the interprocessor communication costs. Is there recent progress on that problem?
Yes, and I wish I had a technical person here to give you more on that, but absolutely. And that's partly why we're having this collaboration with EDCAR now, because there's been some developments in terms of processors, and Amazon recently, or AWS recently, launched this Graviton, or they started using this Graviton processor. And other thing, I shouldn't even be talking here because it's not my space, but definitely. So we've been trying to overcome some of those limitations that in the past prevented, big weather and climate models to be run in the cloud, and that they're now showing the potential to step into this space. So that's really exciting and promising. And I'm very happy to follow up and give you additional details and connect you with the right person that can give you more information if you're interested.
Okay, great. Well, we'll make sure Kevin or others follow up. And you had mentioned that the silver lining project, that's good. Mm-hmm. One more question here, at least one more if anybody submits some more. You had mentioned knowledge exchange as something that's important to help people use the cloud. I think that was on one of your first slides. Mm-hmm. And tutorials are great, having open source software is great, but there's such a variety out there of open source software that is being used to do analysis or whatever on these data sets in the cloud. All of it's differing quality, good, bad, some of it, maybe purpose built and not very reusable, other that's better, more reusable, more generically applicable, maybe has better approaches to things like security. So I'm wondering, has AWS considered identifying any specific software as being kind of exemplary? Like among all of the things that we know about that are being used on these public data sets, try these. It's open source and it's known to work well, both in terms of, let's say, cloud costs, but also security and other best practices.
Yeah, I'm not sure if I could speak on behalf of AWS on that. I could tell you that from my experience working with the community through ASDI and with the open data team, again, our approach has been to provide funding.
Anna, you just muted yourself somehow.
Sorry, can you hear me now?
Yeah.
Can you hear me? Yes, sorry, I must have pressed it by mistake. What I was saying is that, yeah, again, our approach tends to be more like funding the community to go do that experimentation and bring it back as the best practice or the suggestions, and not necessarily us being the ones that are pushing it on the customers. So But again, I sit on the Amazon side of the house, so I need to be careful speaking on behalf of AWS. So I'll maybe elaborate on that through the AWS offline, if you don't mind. I'll
Okay.
reach out.
Well, and I should have written, has ASDI considered identifying any specific software? So some tools related to your sustainability mission and, data usability of the geospatial data specifically.
What we are trying to work, actually, that's something we are exploring internally, is trying to figure out. So there's the universe of software out there, but there's also the issue related to the use of the services on AWS that keep growing by the minute, right? And it's extremely overwhelming for people, and especially in the sustainability space where people are not as familiar with it. I encounter a lot of people that say, I don't even know where to start, right? And so that's something we are trying to address. It's to understand, how do we take this complex universe of tools and services and all these possible combinations that people can use leveraging the cloud, and create some kind of a basic, set of tools that are relevant for the types of problems and analysis that people in our sciences and weather, climate are going to necessarily need to use, and provide a lot more tutorials that are also aligned with examples that are relevant to them and relatable to them. That's another thing. You read a tutorial that is talking about financial data and you're working with weather, it's a little bit hard for you to absorb the information the same way. So we're trying to be receptive and sensitive to those issues, and very eager to get feedback from the community. So if there's things that you understand are blocking your way and that we can help accelerate, being that training, data that needs to be available, or access to compute, please do reach out to us. We're very interested in learning that.
Okay, great. Thank you very much. Looks like there's no more questions. So, and I want to thank you again for your time and giving us this talk, and thank you for your participation at the climate conference last couple of weeks. I understand you were out there, so that's a very momentous.
Thank you. Thank you very much for the opportunity, and apologies on behalf of my dogs and my cold throat. So thank you.
One of the dogs in the background and the kids in the background.
And the kids showing up, right? I don't have that today.
Pandemic, so, okay.
Thank you, everybody. I look forward to hearing more from the feedback. Okay. Great. Thank you.
Thank you, Anna.
Bye-bye.
And thank you, everybody, for attending. See you next year, basically.
Bye.